Today we are going to learn Inorganic Chemistry, P block, Group 15, right? Group 15, right? I think you can remember what are the elements downwards, right? Starting from nitrogen. Okay, then nitrogen, phosphorus, arsenic, antimony, bismuth. Right. Those are the elements belonging to group 15. Okay. Then there's a speciality in group 15. What is it? Nitrogen and phosphorus both are non-metals. Right? These two are non-metals. Right. Then arsenic, it is metalloid. Right? It is metalloid. Okay. Then antimony, bismuth are metals. Right. By looking at this, you can see down the group, the metallic character increases. The metallic character increases. According to the metallic character increases, what happens? Most of the properties of these elements are going to be different. Right? We'll discuss it one by one. But in our syllabus, mainly we are focusing on nitrogen. But in time to time, if we require certain comparisons only, I'll take the other elements also. Okay? Right. Then can you tell me can you think what are the common electronic configuration of this group 5 element? Right? Common electronic configuration, I think all of you can memorize. Right? 5 electrons in the outermost energy level. Therefore, the common electronic configuration NS2, NP3. Okay? NS2, NP3 is the common electronic configuration. Right? According to our syllabus, we have to learn more about the nitrogen, not more about the other elements. But anyhow, if we take nitrogen, oxidation state of nitrogen can be differ from -3 to +5. So there are various compounds that you can see or we involve with these oxidation states. So if you refer your resource book 137th page, right? I'll show it to you. Right. You can see -3 ammonia. -3 ammonia. This is the bond structure, right? Then -2 hydrazine into H4, right? Hydrazine. Then -1 hydroxyamine. Hydroxylamine, NH2OH. This is the structure. Then 0 dinitrogen. Dinitrogen means what we always know as nitrogen gas, right? 0. Then this is the structure, triple bond. Then dinitrogen monoxide, N2O, dinitrogen monoxide. This is the structure. Actually, we can't draw the certain definite structure for that because it always changing in the two Lewis structures, right? There are two Lewis structures. In instantaneous time, we can see these two Lewis structures in certain cases. Therefore, we can't give one structure as N2. Okay. Then the next one, +2 dinitrogen monoxide, NO. This is the structure, dinitrogen monoxide. Then nitrogen dioxide, NO2. Right? NO2 can be drawn like this. You can see that nitrogen is plus and oxygen is minus. What is that plus and minus? Plus means it has already donated 2 electrons to the oxygen, right? Then minus means that oxygen has gained 2 electrons. So acceptor and donor concept. That one is coordination compound or the dative bond is there. Okay. Then dinitrogen tetroxide N2O4. So similar double of this NO2. Right? You can see the structure. Two NO2 molecules get together and form this. Okay. Right. Then plus 5 nitric acid HNO3. HNO3. One OH group is there. Therefore, it has a acidity. Okay. Acidity. Here also the dative bond. N plus and O minus. Right. That is dative bond. Okay. Then N2O5. One oxygen comes in between the two nitrogens. Right. As I told you earlier, if the odd number of oxygens are there in the formula, definitely one oxygen comes in between the two central atoms. Always you should memorize it and keep it in the mind to draw the structure very easily. If there are two central atoms and odd number of oxygens, then one oxygen always should come in between to the two central atoms. Okay. Then we can draw these two structures for this also. These are the oxidation states. So nitrogen has all the oxidation states -3 to +5. -3 to +5. You can refer 137 page of that your resource book. Okay. I will give you a small question. Right, if we consider N2 and P4, right, both are molecules, N2 and P4. But N2 is very inactive. Actually, the normal temperature, it acts as an inert gas, right? Inert gas. Why it is acting as an inert gas? Right? P4 is actually bit highly reactive, right? So how do we explain this? Right? I am going to explain that. You can explain it through the bond structure. Okay? Bond structure. Take the bond structure of nitrogen. Triple bond between nitrogen atoms. Okay? Then phosphorus is existing as P4 molecule. Right? P4 molecule. So the existence of P4 is like this. Right? One phosphorus is always combines with another phosphorus like this. Right? So this is actually a molecular structure. Right? Molecular structure. Then here also a molecule, but if you are going to break break this bond and take one electron outside, then how many bonds you should have to break here? How many bonds? 3 bonds should have to be broken. So when it is triple bond, it is very close at hand because highly attracted to each other. Okay. Then here one phosphorus and the other phosphorus always having one bond with each other. Therefore, if you break this one bond, then the whole structure is going to be reactive because that easily can be broken one bond than breaking this triple bond, right? Okay, that is the reason why the reactivity of P4 is greater than the reactivity of N2. But they are belonging to the same group. Now you can understand why this reactivity differs in P4 and N3. Okay. Then if another thing, next we are going to talk about the oxoacids of nitrogen. Right? Oxoacids of nitrogen. Okay. What are the oxoacids of nitrogen? Earlier also we discussed oxoacids of nitrogen. We can take HNO2 and HNO3. The previous part also I explained what is the structure of HNO3, right? So similarly, try to draw the structure of HNO2. Okay, I draw the structure in double bond OH. This is the structure of HNO2, right? HNO2. Then this HNO2 nitrous acid. Okay, nitrous acid. This nitrous acid can undergo oxidation with the oxygen in the atmosphere, right? It can undergo oxidation. Then what will happen? This HNO2, right? 3 HNO2 molecules, aqueous medium, can given out HNO3 nitric acid AQ, nitrogen dioxide, nitric oxide gas, 3 nitric oxide gas, 2 nitric oxide gas, and water molecule H2O liquid. So that is the reactant product side, right? Reactant is 3 HNO2, then products HNO3, 2NO and H2O, right? That undergoes oxidation. Okay. Then NO is also not very much stable. It can undergo oxidation again. Okay. So 2NO gas plus oxygen gives out 2NO2 gas, nitric oxide. So that is also oxidation, right? That is oxidation with the reaction with oxygen and produce 2NO2, right? Then this NO2 also can dissolve in water and again form HNO2 and HNO3. Okay, when this dissolves in water, right? This NO2 dissolves in water, it gives out HNO2 and HNO3. So if you check the oxidation states of nitrogen in each case, right? Here +4, here +3, here +5, right? +4, +3, +5. Okay. Then what we can explain to that, right? Here +4, +3, +5, right? From here to here, reduction, right? +4 to +3, reduction, right? Then +4 to +5, oxidation, right? Then name given to this kind of reaction, that's the same reaction, same species undergo oxidation and reduction. In that kind of reaction, we explain it as disproportionation reaction. I think you have heard that word, disproportionation reaction. The same species undergo oxidation and reduction. That is one example for the disproportionation. Okay. Then we can talk about the reactions of nitrogen. Then we come to the reactions of nitrogen. HNO3 or the nitric acid is a very good oxidizing agent, right? Earlier we have drawn the HNO3 structure, so I think all of you can draw that. Another thing that it can act as an oxidizing agent, very strong oxidizing agent. If we take HNO3, it can be dissociated into nitrogen dioxide, oxygen and water, right? This won't happen generally if it exposed to the sunlight or the HNO energy is being given, then HNO3 can be dissociated into NO2, oxygen and water. Okay, so this is concentrated HNO3 acid. Okay, concentrated HNO3 acid is a viscous liquid, right? Very strong viscous liquid. Okay, then next we are going to move on to the reactions of nitrogen, right? Reactions of nitrogen containing acids, right? Mainly HNO3. Okay, but first one with the metal, right? Magnesium plus HNO3. If it is dilute HNO3, acid metal reaction, it is very familiar to you. What are the products? Salt and magnesium nitrate and hydrogen, right? Magnesium plus dilute HNO3, that is important, dilute HNO3, and it produces magnesium nitrate and hydrogen. Right, if we use magnesium with conc HNO3, then the products are different. Okay, the magnesium nitrate, same product, magnesium nitrate plus the next product is going to be changed. It is nitrogen dioxide and water. So it is special. You have to be memorize this, no other method, right? So magnesium with dilute HNO3, normal reaction, what we have learned earlier, metal and the acid reaction. Okay. Then the next one, magnesium and conc HNO3, but that reaction is different. Okay. Magnesium nitrate, nitrogen dioxide and water. Okay. Similarly, copper with HNO3. With dilute HNO3, according to your previous knowledge, you know that copper below the hydrogen in the activity series, right? In the activity series, copper below the hydrogen. Therefore, copper can't evolve hydrogen gas when if we added the HNO3 like acid. Therefore, what is the product? But there's a product is going to be given in this reaction, right? So, what is the product? Copper nitrate, nitric oxide and water. So, you have to memorize this because in the MCQ questions, mainly they are focusing this kind of special reactions. So, you should be memorize all these things. Okay, right. Then copper with conc HNO3. Conc HNO3, copper nitrate plus NO2 plus water. So, what is the difference? Right? With the dilute HNO3 and copper, nitric oxide. Copper and conc HNO3, nitrogen dioxide. That is the only difference. But other products are same. Okay? You should write the balanced equation accordingly. Right. Then another reaction type with the HNO3. HNO3 is very strong oxidizing agent. Therefore, it can react with carbon also. Right? But conc HNO3, carbon solid plus conc HNO3. What are the products? Okay? Carbon dioxide gas, right? Then NO2 gas and water. NO2 gas and water. Those are the products. So, this also should be memorized. Okay, this also should be memorized. Carbon, conc HNO3 gives out carbon dioxide, nitrogen dioxide and water. Okay. Then similarly, the reaction with sulfur solid, conc HNO3. Conc. Right. Now you can guess. In this case, it goes to H2SO4. Right? H2SO4, nitrogen dioxide and water. H2O. Right. How do you memorize this? Okay. You can memorize it. This is the strong oxidizing agent. Therefore, carbon and sulfur both are going to their highest oxidation state. That is the theory, right? That is the theory that you can memorize the product. Okay? Carbon goes to its highest oxidation state. What is the highest oxidation state of carbon? Plus 4, right? Plus 4. Sulfur highest oxidation state? Plus 6. Therefore, it forms sulfuric acid. So, very simple, right? So, when you are going to memorize these things, please prepare your own way. If not, it is very hard to memorize this stuff, right? So, you should know the basic things. Then it is very easy to memorize. In such a case, with the concave HNO3, it is very easy to memorize all elements. The elements which are reacting like carbon and sulfur, all are going to the highest oxidation state. So, easy to memorize. Okay. Then we come to the ammonia and ammonium salts. Okay, ammonia and ammonium salts. Right. NH3. This is ammonia. You know, this is a covalent compound and it has nitrogen has one lone pair on ammonia. Okay, so it can involve in the dative bonds also. Right. Then in this case, if we take ammonia, right, ammonia, this ammonia can react with water. What is the product? Ammonium hydroxide. Right? All of you know this ammonium hydroxide is slightly basic, right? Slightly basic. So, how this ammonia is combining with ammonium hydroxide, right? You can draw it also, that nitrogen, this is ammonia, one lone pair is there. This water can be done its self-ionization, right? Self-ionization. According to the self-ionization, what happens? H plus and OH minus given to the medium. So that H plus can gain these two electrons like this and it forms NH4, tetrahedral shape ion, tetrahedral shape ion, right? So that is the ammonium ion. Then the OH minus is remaining. This is completely dissociates into NH4 plus and OH minus, right? That dissociates into that, not the complete. It is partial dissociation. You are going to learn that how much dissociation can be happen and all the calculations in your 13th unit, chemical equilibrium, right? Up to now we have not going to discuss how this dissociation happens and all. Okay, then this is the phenomena, right? Then if this dissociation is written ammonium hydroxide AQ, it's a partial dissociation NH4 plus AQ and OH minus AQ. Okay, it's a partial dissociation. Anyhow, OH minus comes to the medium. If OH minus comes to the medium, what does it mean? Medium is basic. Okay, medium is basic, right? Then if the medium is basic, that ammonia dissolves aqueous solution is there, and if it reacts with an acid, what will happen? Right? What will happen then? If HNO3 or any other thing, right? So what will happen? Right? If we take with HNO3, that ammonium hydroxide with HNO3, acid-base reaction, right? It is acid-base reaction, general reaction. So what are the products? Ammonium nitrate plus water, right? Ammonium nitrate plus water. Okay. Similarly, if we take the reaction with ammonium hydroxide with sodium hydroxide, is there any reaction? Think about that. Ammonium hydroxide and sodium hydroxide. Is there any special prominent ion or their compound is given? Now both are bases, nothing will happen, right? The ions can be in the medium. Okay. Then another thing, if we take ammonium chloride, this is big special, ammonium chloride. Right? This ammonium chloride, when it reacts with sodium hydroxide, it produces sodium chloride. Okay, sodium chloride, ammonia and water, NH3 and H2O. Right. Salt, ammonia and water. So how does it happen? Right? If we take ammonium chloride, okay, ammonium chloride, it completely dissociates. Ammonium chloride, AQ, completely dissociates into ammonium plus AQ and Cl minus AQ. Right. Then ammonium plus is in the medium. This is the aqueous medium. In the aqueous medium, yes, H plus and OH minus are also in the medium. Therefore, ammonium can be formed, but it can form ammonium hydroxide also, right? Ammonium hydroxide. Then H plus and Cl minus is also there, right? Then that ammonium hydroxide partial dissociation forms NH4 plus and Cl minus, okay? But HCl is a very strong acid. Then anyhow, that H plus and OH minus comes from the same molecule of the water, right? Then think like this, there are 5 water molecules have already dissociates, right? Then how many H pluses? 5. How many OH minuses? 5. Okay? Then ammonium hydroxide grab that OH minus and then it not dissociate completely, right? Not complete dissociation. Then what will happen? It is not the complete dissociation, therefore some amount of OH minus is reducing in the medium, right? Therefore we see H plus is greater in the medium than the OH minus. According to that, we can see the acidity rises when we dissolve ammonium chloride in the medium. So this is like acid-base reaction, right? So this phenomena is called salt hydrolysis, right? I think now you have idea what is salt hydrolysis, right? Because of the salt hydrolysis, the aqueous solution can be acidified, okay? Similarly, it can be basified, but we are not going to discuss it in detail. We are going to discuss in detail in 13 unit, okay? Now we come to the reactions of NH3, right? Reactions of NH3. Ammonia can react with chlorine, right, and produce nitrogen gas and HCl, right? Nitrogen gas and HCl, but with the excess of ammonia, right? It is special. Excess of ammonia plus chlorine products are nitrogen gas and hydrochloric acid, right? Hydrochloric acid. So similarly, if we take ammonia and excess Cl2, then the products are going to be different, okay? Products are different then. HCl and NCl3, that is different, okay? So you have to memorize this, no other method to remember it, okay? With excess ammonia and plus chlorine, nitrogen and HCl, with ammonia and excess Cl2, HCl and NCl3. So that is first reaction of ammonia. Then we come to the next one, ammonia gas with HCl gas. What will be the product? It forms ammonium chloride. Ammonium chloride solid. White color fume, like white color solid. So this can be used as the identification reaction of ammonia, right? Because we can hold the conch HCl lid, right? In the reagent bottle, conch HCl lid can be held over the evolving gas. If after holding it, it gives out white color fume, what does it mean? The evolved gas is ammonia, because it forms the ammonium chloride solid. So it is also important, that can be used as the identification reaction. Okay. Then the next one, copper oxide and ammonia. Copper oxide and ammonia gives out nitrogen, copper and water, right? Copper oxide, actually this done that through the heated copper oxide. Ammonia passed through the heated copper oxide, then you can get nitrogen gas, copper and the water. So this all should be memorized. Okay. Then the next one, magnesium with ammonia. Okay, right. Then copper oxide and ammonia reaction, and ammonia and chlorine reaction. Right? In both of these cases, ammonia is acting as a weak reducing agent. Right? Weak reducing agent. You should memorize. If the MCQ question asks, give one example. What is the example for the the ammonia is acting as a weak reducing agent? Then these are the examples. Okay. Then we move on to the next one. Ammonia can act as an oxidizing agent too. Right? Oxidizing agent. What are the examples? If ammonia reacts with magnesium, right, it can produce magnesium nitride and hydrogen. Okay. Similarly, if sodium and ammonia, then it can form sodium amide NH2, sodium amide and hydrogen gas. So in these two cases also it is bit different, so you have to memorize, right? Magnesium with ammonia, it forms magnesium nitride and hydrogen gas. Sodium with ammonia gas, sodium amide and hydrogen. Okay, but in this case, in both cases, it is acting as the oxidizing agent. Ammonia is acting as an oxidizing agent. Okay. Now, what you have learned about the ammonia? Ammonia can act as a weak base. Okay. Then ammonia can act as reducing agent, and ammonia can act as an oxidizing agent. Right. So we have discussed all the examples. Right. Then we move on to the thermal decomposition of ammonium salts. Right. Thermal decomposition of ammonium salt. Right. We take one by one and see. Ammonium carbonate. Right. Ammonium carbonate. Thermal decomposition. What will be the product? Ammonia, right? Ammonia gas, carbon dioxide and water. Carbon dioxide and water. You should write a balanced equation for all. Right? I am only telling what are the products, right? Ammonium carbonate thermal decomposition gives out ammonia, carbon dioxide and water. If we take ammonium chloride, thermal decomposition, all are solids, right? Thermal decomposition, ammonia and HCl gases, right? Ammonia gas and HCl gas, okay. Then ammonium sulfate, NH4 twice SO4, thermal decomposition, right? It can produce ammonia gas and H2SO4, okay? H2SO4. But this reaction is special because it always depending on the given conditions, right? This is under the normal condition. If the condition changes, it can be changed. Anyhow, you should memorize what are the products of the thermal decomposition of ammonium salts, okay? Ammonium salts, right? Then another special cases are there. If you take ammonium nitrate, right? Ammonium nitrate, it produces N2O gas and water. That is special. If you take ammonium nitrate, then it produces dinitrogen oxide and water. Okay, not the ammonia. Ammonium salt, but it is not producing ammonia. That is special. Then if you take ammonium nitrite, NO2, sorry, all these are solids, right? Okay, then the product will be nitrogen gas and water. Now you can see the difference, right? If we heat ammonium nitrite, it produces nitrogen gas and water. Ammonium nitrate, it produces dinitrogen oxide and water. So no other method, therefore definitely you should memorize this, right? You should memorize it very well. Okay. Then we'll take the ammonium dichromate, Cr2O7. Okay, ammonium dichromate. The product nitrogen, chromium oxide, dichromium Cr2O3, right? Trioxide and water. That is also giving the different product than ammonia. Okay, so now you can always try to make the short note, right? Take the comparison like this. These three ammonium salts are giving or producing ammonia when it is decomposing, right? But these three ions or these three compounds are not giving ammonia when it dissociates or the thermal decomposition. Okay, so they are giving nitrogen and N2O like that. Right. Identification of ammonium salts. It is very simple. Ammonium salt, ammonium plus, right? It reacts with HCl. It gives out ammonium chloride. It is a solid, right? Ammonium chloride is a solid. We can use this as the identification. As I told earlier, if we use the lid of the conch HCl bottle and hold it through the evolving gas, then it produces white fume. That white fume is ammonium chloride. That is the identification of ammonium salt. Right. The next one, reaction of nitrate, NO3 minus. We can use to identify these nitrate ions by using sulfuric acid and Fe, ferrous chloride, right? Ferrous chloride or ferrous thing, right? Then what we do is we add the nitrate to the NO3 minus containing salt to the test tube. Nitrate ion in the test tube. Then add freshly prepared Fe2 plus to this one, right? And then then you can see the brown color form at the top, right? That is brown color ring or brown ring. These are the reactions, okay? These are the reactions. NO3 minus plus H2SO4 plus Fe2 plus, right? These are the reactants in the medium, and it produces Fe3 plus and NO gas, nitric oxide gas, sulfate and water, okay? NO and sulfate and water, right? Nitric oxide, sulfate and water, right? Then this brown color given by this compound, brown color given by this compound FeNO2, F2 plus ion. This is a complex ion, right? Next lesson, D block, we are going to learn how to label these or IUPAC nomenclatures of these ions and compounds, okay? So we can write it Fe2 plus NO goes to FeNO2 plus, right? NO is a ligand, actually it labeled as a ligand, right? Fe2 plus remaining as it is because NO is neutral compound, okay? So this gives the brown color or the brown test ring by this brown color ring formed by through this reaction, and you can identify nitrate ions, okay? Right. Then another reaction, aluminium and sodium hydroxide. Aluminium and sodium hydroxide. So if you use aluminium and sodium hydroxide to nitrate, what will happen? Right? NO3 minus with aluminium and sodium hydroxide. Also can use as the identification reaction. Then we see what are the products, okay? Then here OH minus is also there. OH minus is given by the sodium hydroxide. Then water is also there, right? Then the products, ammonia gas and aluminium hydroxide complex ion, right? Hydroxido aluminate ion, right? Tetrahydroxido aluminate ion is formed, right? You never mind about writing the IUPAC nomenclature of this. Just memorize it like ammonia plus aluminium hydroxide, okay?